No problem, sir. Your voice is audible. Please continue, sir.
Hmm. Okay, so my phone is on and I am now continuing.
Okay, sir. Thank
So,
you, sir.
first of all, uh, let me apologize, give me excuse for all those technical glitches because I'm giving a talk after 1.5 years in online. So, it is my apology for that. And anyway, as it is already must have told you about my topic and from where. Anyway, this is a little old designation. I am now Associate Director for ARCI. Topic of today's presentation is synthesis of carbon nanomaterials and their applications. So ARCI, I will just tell you about some detail about ARCI. ARCI is a research lab. This is our aerial view of ARCI. When you come to near airport in Hyderabad, this is located in Hyderabad. This is a Department of Science and Technology Research Lab. So this is an autonomous research center. So of Government of India, we are about 180 employees. Out of them, 80 are scientists and 55 are technical cadre, and 45 about administrative and supporting staff. And we have about 120 numbers of students. And all other services we have outsourced, like electrical, powers, security, and other things are outsourced. Okay. Now, the mandate of our ARCI is very distinct from the other lab. We develop the high performance materials and the process for the niche market. Niche market in the sense, suppose we work on composite. Composite is not used for the general purpose. It is used for the high-end application, strategic applications, like our space or defense or atomic energy. And or else if we work on to that a prototype development through a pilot scale scheme where we can demonstrate the technology and then transfer ultimately this technology to the Indian industry. Now, and then sometimes what happens, industry also comes to us for a solution, whatever problems they are having, because during their operations or during in the materials, they come to us for the solution and we try to provide the solution for them. Apart from that, we are regularly taking students in all streams of whatever centers we work. So we also develop a lot of human resource for this. Now this whole ARCI is divided into materials-centric centers, like Center for Carbon Materials, Center for Soil Gel Coating, Center for Ceramic Processing, Center for Solar Material, and the Laser Processing, Engineering Coating, Nanomaterials, and Center for Characterization. And we have two centers located in Chennai, that is Center for Fuel Cell and Center for Automotive Materials. And these top four centers, I am the associate director for that: carbon, soil gel coating, ceramic, and solar material. And apart from that, we have one center in Gurgaon that also is a corporate sector. That center also I am heading. Now, if you see critically the Center for Technology Transfer, apparently it looks very strange because not many institutes are operating such type of centers, but we operate with a special mandate that we want to transfer our technology, because industry sometimes don't understand the technical strength of the technology, or we don't understand the money value. So this center acts as like a bridge between the industry and the technical center. And if you just, I'll give you a brief about all centers, what they work. This is a center for ceramic materials. This is a for we work on transparent ceramics and cellular and porous. All these things are available in the website. So, but some of the things what we do, like apart from that, whatever you can see, I think I can put a laser. Is it cursor is visible? Not visible.
Yes,
okay.
sir. Visible,
so
sir.
This is a That's the problem. I'm not able to hear anything from your side. Hello? If I remove the headphone,
Yes, sir. Visible, sir. Continue, sir.
when you are talking, I'm not able to hear anything. I
Oh.
think I have to mute it. Okay, no problem. So this ceramics like ceramic balls, and now we have started a very important program, low expansion glass ceramic, which is used for our space application, defense application, all strategic sectors. It is there, and this is a center for silicon carbide. This center works onto the silicon carbide mirror for high temperature satellite and other operations. So this unique facilities in nearby area, and like this silicon carbide mirrors are there, which is used in fact one of the component has gone into Aditya mirror, our satellite mission, and for mission Shakti. So this type of small production as well as the development we undertake for all these things. This is a center for laser processing. And where laser based techniques are there, we have all sort of laser. You just name it, whether it is a laser, different processing, laser hardening, laser brazing, laser hybrid welding, all those things are there. You can just see that a complex engineering components is also processed through laser. We have all and micro machining, if anything, to be machined into a microns level also, that can also be undertaken. This is a engineering coating where we have all sort of engineering coating facilities like thermal spray, plasma spray, electron beam spray coatings, and this is a very good center which provides all support to our coating activities, because nowadays what is happening, the functional coatings are very much required, like thermal barrier coating, where you want to use the coatings for removing or like an insulating purpose. So this type of processes we undertake for that industry also. And this is a center which is on the nanomaterials, like sorry, this is for solar coatings, and which one on work on the solar selective. All these things, if you see the sol preparation, the different type of colored coatings, and in fact you can biodegradable coatings. All those coatings are possible through a sol gel. This is a solar materials. So all panels and other things, solar activity, thermal panels, you can see this type of center, and we have a unique facility for CIGS solar cell. So those centers, this center, whatever I have shown the initial center, they are now this is a nano center which work on different type of nanomaterials like zinc oxide and nano silver for the coating purpose, nano oxide disperses, strengthen steel. All those activities are taken up. This center is in Chennai, which work on the hydrogen synthesis, the PEM fuel cell. All these activities are there in Chennai, in IIT Research Park. These are the facilities which is in the Chennai. And this is a automotive materials for magnets and other things are there, battery materials. All these activities are undertaken in Chennai center. This is a carbon center where we work on the graphite, the flexible graphite, the aligned carbon nanotubes, everything we work on it. These are the few products what we have developed. We will see in initially how it works. Now this center is a characterization center. You just take it any characterization facilities, whatever is required for the materials development, almost all we have in our ARC. And we offer services for the external agencies also, institute also, whether it is research or something, with a nominal rates. Now, these are the few technologies which we have transferred to industries. To some of them are multiple transfers, like not only one unit, the exclusiveness is not there. Sometimes we transfer to many companies. Here the last two activities. So these two activities, I was the project lead, and earlier whatever this right now the numbers have increased to 28. This year we have transferred 4. Now coming to this is a very important slide, which because I wanted to see all the those who are participant, what level they are, because if they are the faculty, young faculty, or the senior faculty, or the scholars, I'm not aware. But this is a very important slide in a way, because what is happening, unless you work, your work is defined into any category. The TRL level we call it, technology readiness level. So suppose a basic research is there in the many institutes or many IITs where the research is at the small lab level. So it is called under the research category either TRL 1, 2, 3. But unless you prove it into a field trials and other things, you validate into a relevant environment, then only it will come into development. And then after development, the full technology, then this whole technology goes into the actual deployment. So the whole TRL system is divided into 1 to 9, and this is a well-established system. And we have designed our own this system into mapping with our materials development. Suppose any technology is there where it is, whether it comes on many times idea-based technologies are there. So we take, that's what I told. Suppose if we want to produce any powder or anything, we have to produce into a kilogram level. Then only industry is getting confidence that it is doable. I can see, okay, some chat was there, but it's okay. So this is very important. And now coming to another. Now coming to the overall development of materials, how materials influences the overall the civilization. If you see the whole last, because we will not talk about the old Stone Age or something, because all civilizations are driven through the materials, whether it is Stone Age or Metal Age or Bronze Age. The materials are the driving force for any developmental civilization. So, but we will not talk about the thousands of years. Just in the last century, if you see, the vacuum tube technology was there, where we have seen the television, radar, radio. These are the things which internationally we have seen. And then it comes to a semiconductor technology, where we have seen the cell phones, internet, computers, transistors, radios, etc. But now this era of 2000 to 2050 is the era of nanotechnology, or nano robots, or even the nanobiotechnology. Why this nanotechnology is so important, we will see in the coming slides. So if you see all these gadgets, in last 15 years, these gadgets were the part of our system. In our every household was having a radio, or the movie, or the video camera, or even the alarm clock, the telephones, with the wire telephones, fax machine. All these things got disappeared. Now everything has come into our hand. Okay. So all the functions, whatever earlier those component equipments or the gadgets were doing it, now this alone can do. So that is a sort of everything is confined to your hand. Now coming to, if you see what exactly is the new, first about the nanotechnology. But is that so new nanotechnology that we have to understand? This is not a new concept of nanotechnology. Even the 4th centuries also, we have seen that in Europe, Lagergus cups where you just gold nanoparticles are in glass. When you transmit the light, the green color will convert into red color. Even the high-rise buildings, or even the many buildings or museums are having a colored paint, which is still very good after 1500 years or something also. So nanoparticles were being used earlier also, our this thing. Now if you see the ancient tools also, if you see the Mohenjo-daro, Harappa, these artifacts, when the microstructure was taken up, people have found that nanoparticles were there. But the point here is, in contested, like this kajal or katuka or whatever you see, people were using this for many centuries. We don't know, maybe few thousand years people were using it. And such a sensitive organ, eye, which was being used by a black color powder, and people were using an eye. So our ancestors were knowing that this black powder will protect eyes. But now we have tools. We know that these are nanocarbon, which can protect the eyes against the ultraviolet rays because they can absorb the ultraviolet rays. Now the nanotechnology, you can say that nanotechnology was existing, but it has people have started realizing its importance, or they can start correlating the properties with nano because now equipments are there. The high-end sophisticated microscopes are there. Because of that, we can see the nanostructured particle. Like you will be surprised here then when we say microscope. Microscope means any things where we can see the micron size. Because 50 years back, people have never thought that anything can be smaller than the microns. That's why the name was given microscope, not nanoscope. But we are seeing the nanoparticles under microscope because 50, 60 years back, people have never thought that nanoparticle can also influence the overall properties. Now, all these things were there, but all of a sudden in the last 20 years, people started talking about nanotechnology in a big way. The reason was very simple, because this is in any can affect in all areas. You just see in any search engine, you just take the hits of nano, you will find many multi-millions of hits, because this is the word which is, or this is the technology, or this is the impact almost in all field of science and technology, whether it is the defense, or it is electronics, it is space, it is biotechnology, or it is even the sports goods, domestic goods, cosmetics. Everywhere you will find nanoparticles or nano effect of nano is there. And another very important reason is it is having a very big money. All governments wants to give a good amount of money into this nanotechnology. We will see why this nanotechnology, why government wants to give big money, because this is the technology which can influence, which can give you a leap jump into the technical words. Just imagine the materials importance. When I have shown you the graph of electronics and the last century, you will be surprised to know. I'll give you one example. Like Japan, after the World War, Japan was almost a destroyed country, but they have developed a one material called silicon, and they found the electronic application of silicon, and they don't have any natural resources, no very small country, just because of few technical upgradation, and then all big companies, Sony, Panasonic, Akai, all those things have come, and Japan has become the third largest economy of the world. They don't have, mind it here, I just remind you, they don't have any natural resource, everything just because of the material development. They became the number 3 in the world. Now, when we see, suppose if you see here, most of the students or the faculty, if they want to do research, what they do, they just go to the Google and just see what is happening in the world and try to make their work according to the search. Suppose if it is a coatings or it is a new development, so Google is their driving force. But have you seen that who is putting those things into Google, or those who are doing the first time, who is the driving force for them? The driving force for them is always a nature. Natures drive them, that the concept of natures are very, very unique. Just for example, if you see here, I will try to do something. Okay. So like if you see here in the first corner, I don't know whether pointer is seen or not. Cursor. Okay. So the
Sir, cursor is visible, sir. Sir, cursor is visible.
hello. Hello.
Sir, cursor is visible, sir.
Oh, visible. Oh, then it's okay. That's what I'm not able to hear. Okay. Now see here, that design of this aircraft, advanced aircraft is coming from this all birds. So all those designs, if you see the spider net, the thickness is very, very fine. The specific strength is very high. And this is the motivating feature to get the fiber strength in whatever our natural fiber we are developing the synthetic fiber, whether it is carbon fiber or any polymer fibers, that the motivation has come from the silkworm or even the spider worm. If you see the lotus leaf effect, the lotus leaf effect, hydrophobic, all those things are there. But because we understand the science, and the same concept is being used in our most of the technology where the repellent technologies are there. Just one example, the mosquito. If you see the thrones, whatever it is used, the same mosquito is sitting in the place where he or she can suck the blood. So it acts as a sensor. It's thrown as act as a sensor, and then the same thrown is used to drill. So drilling it, going deep into the skin, and then after that, the same thing is used as a sucking machine. It sucks almost 5 times of its weight, the blood, and then it flies off. It becomes like a flying machine. So can you imagine such a small nano machine which acts all the 5, integrating all these functions into one? And that is the driving force of the nature. When we see, then only we realize nature is really, really great. And all scientists, whatever we are doing, this is the driving force. Now, once upon a time, this all things were into the functional requirement was there. Whether it is like in a world war to supervise or having things to keep eye on to those people, enemies or something, such type of person used to. Now, another example is about the dresses. Whenever a fighter or soldier used to go, the technology sometimes goes very, very fast. And this is the last 50 years. We are seeing things now after the introduction of AI and other things, things are going in a more dynamic mode. Now, it looks to be very simple, but these fantasy movies in the mid 50s, these Hollywood movies were showing a Superman is wearing a dress which can reflect as a bulletproof jacket. Spider dresses where a person can put and then climb onto the walls is a hollow man. Hollow man means you don't visible. Now here the concept of hollow man is not a really hollow man. Hollow man means invisible to the radar. Now our missiles are given a coating, or our aircraft are given a coating in such a way that they are becoming invisible to the radar, and that's why it is the concept is how you take it. What is the reason for visibility? So if you suppress those regions, you will be into a different zone. You can fly. There are now dresses, or there are things by which people can you have seen also in the movies. Now in our old Mahabharat Granth, as you have kilometer 90, I don't know, 90 miles or 90 kilometers, the distance between India and Sri Lanka. So he could be able to fly. Now there are things people are working on it. So these are the motivation. Even the Pushpak Viman. It looks to be very people but don't realize. But just imagine, mankind has imagined such a machine where people can sit and then fly from one place to the other place. That to be not this our aircraft engineering has started hardly 120 years back, but this we are talking few thousand years back. Now we are going to talk about the few new applications of nanotechnology. Now, when nanotechnology has come, people were thinking like, have you heard about that technology called superconductivity? 30 years back, superconductivity was in a big buzzword. Every research institute was working on superconductivity. Okay. And I also did in 1987 my MPhil on superconductivity, because that was the peak of superconductivity, and I want to go. But somehow, slowly, then superconductivity could not fulfill the need of the society. Society has discarded. Society is very cruel. If you are not fit for them, they don't care. So nanotechnology, people were also having inhibitions that nanotechnology will also become like a hoax, or not able to sustain the need of the society. But fortunately, nanotechnology is into the many fields, whether it is sporting goods, paints, coatings, computer chips, nanocomposite, sun cream, nanotexture, all those things. If you see, you'll see some few examples out of that. You see, like all our stoves, gas stoves are there. Even if a spatula falls on it, there's no scratch. There is a scratch resistance coatings. Even in the here in the washing machine, if you see, the nano silver coating is given, and those coatings are lasting for long. This look to be a microwave oven, but this is not a oven. This is a shoe rack, where if you are having a shoe locker, if you are having a lot of bad smell, it will just take away. Like people want to use socks for many days, they just keep the socks here, and then all the bad smell will go. In the cosmetic group, you see all those creams are there, which is going into the very strongly, like ZNO in this thing. Like 5 years back, when people were talking about air purifier, so people were thinking it is only for elite class. But after COVID, people have realized the sales have gone almost like exponentially very high. Now this purifier has become an inevitable part in the many offices. So these all are there, which is having a nano coating. Now this, if you see, the surgical tools, all tools, if it is having a rust or something, it cannot be used for the real good surgical purpose. Or even the kitchen tools are there, utensils are there, the watches which is coming with the gold plating and other things. All those things are having a very high-end coating. But forget about all those. Now these are the floor where if you give a coating, the no droplet will stay. They will be wiped off easily. And such in the roof also, you can just apply the coating, so it will not stay. These are all 1 floor, 2 floor houses. But you just imagine a Burj Khalifa, 150-story building, you want to paint it. Now, what type of technique, which will like a Jhula technique, where people will hang on and then go for a brush or something, is possible in 150? Not possible. So you have to apply such a panel, which is having a self-cleaning coating. So this self-cleaning coating will be applied onto such panels, and then by nature, it will be taken care. So you don't require any special type of things. Now even the sun creams are there. So ultraviolet rays protection creams are fitted with that. This is very, very important. Those who people don't realize it, but the packaging industries is in a big way. It is increasing by more than 20% growth. Now everything, even your food, Swiggy, Zomatos are supplying within a half an hour. No problem. If you want to take the Hyderabadi biryani to your Vijayawada or Vizag, you require a special packaging. It is an overnight journey. But the same thing, if you want to carry to US, you require a different type of packaging. So a lot of food items, or even the normal societal this thing like shoes. Like I'm from, just say example, I'm from Agra. My native place is Agra in UP, which is very popular for shoe making. So one of my friend got an order of a big shoe number supply in Switzerland, and he has supplied 1,000 pairs of shoes to Switzerland, and all thousands have come back because all shoes were having a fungus. He has not realized for a cold country, the leather has to be protected in such a way that it can no fungus should come. So that type of things, your product will have but this packaging industry is growing very, very fast, very, very strongly. And these dresses, like these were earlier 3 years back, all these dresses were not very common and people were using only for chemical warfare or something. But now it has become very common after COVID. So here also we use the canisters where they activated because you have to breathe. So if it is a chemical warfare, so which gas you are going to breathe it. You cannot carry a oxygen cylinder with you for every time. So you require a special type of carbon which is filled in this canister, and it will absorb all gases, whatever is not required for the human beings, and then you can breathe comfortably. Even in your targeted drug delivery system, this looks to be very not very popular in India. But when a person unfortunately suffers with the cancer, a lot of chemotherapy, a lot of radiations treatment he has to undergo. Now, this treatment is not only kills the cancerous cell, it also kills the good cells. So that's the reason people, they will get the swallow, they will get all sort of a swelling in the body, the hair falls will be there, they become little not in good shape, they will become little ugly, and all those things. So now this nanotechnology has come out where they can be used for the targeted drug delivery system, where they will be targeted in such a way that only cancerous cells will get affected and the good cells will be protected, will not be, treatment will not be there for the good cells. So that's why only the treatment will be for the cancerous cell. Now if you see the creams, these creams are being used in your hands, like if you see here, the one half is looks like there is no cream, whereas the second half there is a cream. So it means that because the nanoparticles are dispersed on the right hand side, and that's why the cream is not visible. And apart from that, when you apply a nano dispersed particle, they easily penetrate into your body and heal the wounds or whatever you are having it. Now, even this in cloth system, this cloth, if you give a coating, the cloth will become will not wet, whether any coffee or liquor or anything will fall on it, and then you don't require to wash it more frequently. Now, India is a tropical country where the water is a big issue. So what is happening? Why we are washing cloth? Because it gets contaminated, it gives a bad smell because a lot of dust will stay into that. Those who have visited Europe or the cold countries, the same clothes will continue for 3 to 4 days. You need not to wash it because it is not that every day you are compelled to wash here because it gives a bad smell. This bad smell is because of the dust particle and the bad things stick to the cloth. If that does not stick, you need not to wash. So you can save a big quantity of water. Whereas in India, a lot of people are not having a drinkable potable water. And you know, we are in Hyderabad or in Telangana, nearby Maharashtra. You will not find people brings water, one bucket from few kilometers. And there is a specified days when water will come. So we are very fortunate. We are living in such a society where water is not an issue, but we have to preserve that water for the coming generation. Now coming to this rackets and other things, they are also made from this nano wire, nano things. I'll show you one example like tennis, lawn tennis. Have you ever seen that? Earlier, the big players like Bjorn Borg, those who knows 50 years back, he was a very popular, many times Wimbledon champion. But his service speed was about 125 miles per hour. Whereas now, Nadal is serving with 160. So can we say that Nadal is more powerful? No. Bjorn Borg was also very equally powerful. The only thing is the racket gives an extra flexibility, extra impact, so which gives an extra speed to the ball. And that's similarly in your this thing, because the flexibility in the racket or lightweight, so it will give a more impact to the ball. Now all these things are nanoparticle. You can see the colors are there because it's changing the particle size. You will get a different color, and we can explain it from the adjacent emission spectrum. Now, all these things are very common, not an issue. The problem is why nanotechnology is so popular. It is the surface area which makes it very, very impactful. Now, you just imagine a one cube. These are all in internet, so nothing new. Those who may be named, but just kindly bear with me because this will give you some understanding about nanotechnology, because some of the faculty members or the students, those who are not in the field, they can understand it much better. If you take one small cube area, the surface area of this cube is about 1 centimeter, so it becomes a 6 centimeter square. But if you break this cube into 8 pieces, and each pieces again you break into 8 pieces, and you repeat it about 24 times, you will get the same from a one cube. You will get a powder which can cover the football stadium. You just imagine the quantity required is very, very small, but the functionality can be covered up to like a one football stadium. So that's the impact of the nanotechnology, where the small quantity of a material also can fulfill the requirement for a bigger scale. Now, apart from that, the surface to volume ratio is another important property. Now, if you see, the particle size, which is about 10 micrometer, will give you a 0.22 meter square gram surface area, whereas the same 50 nanometer particle size reduction will give you 44 meter square per gram. Now, if you see, if you see the many particles comes to the surface, they only will participate into your functional activity. So you want more particle to come onto the surface. Suppose you have been given a hot milk by your mother and you are in hurry. If you want to drink the milk, what are the possible ways you will make it cool? This is one way, from pouring one container to other container, putting that milk into a bigger container which is having a big wide and this thing, or start putting this container to rotating into a water filled container, and or else start giving the blowing from a mouth and drinking. In all the cases you have seen, we are trying to bring more particle onto the surface. Whether when we are pouring from one container to other container also, what we are doing is we are bringing the more particle onto the surface so that they can dissipate the heat. Okay. Similarly, this type of concept is there. Now it comes to a nanotechnology. As I told you, this is only a size which can be achieved either by reducing the bigger particle, or you can be go with the atomic layer by layer. You can go, and it is called bottom up or top down. So there are only two schemes are there. It is only either top down or bottom up. There is no other scheme. So all the synthesis techniques will fall only in these two categories. Now in top down or bottom up approach, there are certain benefits and other things are there. If you see the top down approach, it is less expensive. You just take any ball mill and you will get it. But you have a lot of challenges like irregular. You cannot control the morphology. You cannot control the size distribution. You cannot. There is a possibility that defects will go. So all those things are there. And in a bottom-up approach, you can use, but it requires a very high costly chemicals, solvents. So each one is having its own strengths and weaknesses. So depending on the application, one can go with that. This is a very, very important. Why this nanotechnology why government is putting the money, as I told you in the beginning. Because once the particle size is then nano, it's all electrical properties, magnetic properties, mechanical, optical, chemical, all properties can be altered. Now you see the melting point of iron is like 1400 plus, it will melt at 700. The density is coming down. The color is changed. The gold is not yellow in the nanoscale. The aluminum become pyrophoric. The density of carbon nanotube is low. The strength is low. The conductivity is different. So what is common? Only common is name. So it means we are into a juncture, or we are in a position where we can redefine the periodic table. because each particles, say carbon or iron or tungsten, are not having the properties what we used to read in decades before. Now we are having a new set of properties, mechanical properties, magnetic properties. Every property is changed now when the particles becomes in nano. So that there comes that there is the possibility you can play with them. You can manipulate the properties as per your need. Now coming to the carbon. Carbon is a material which is blessed by nature because it can be one of the hardest material in the nature, the diamond, because of its structure. It can be porous. It can be in a ball form like fullerenes. It can be very soft like graphite. Those who know the pencil, even the LKG student can write. So one layer of graphite goes off. So very, very soft. Even by hand, if you put it, your hand will become black. But the diamond is so hard that the hardness is ultimate. All the materials hardness is measured with the reference to diamond. So carbon is enjoying all the properties. The hard material is white, it is black. All those things are possible. You will not find any other material which is so variety of possibilities are there. And all these things are happening because of the structure of carbon. As I told you, it can be one of the hard like diamond, graphite or carbide or fullerenes. Everything is there. Now diamond is, we will not talk about diamond because that itself is a big subject. Apart from your ornaments and other things, it can be useful for the industrial application for abrasive material. It is one of the best abrasive materials. Those who work in the lab, they must be knowing when you are going for a polishing, high-end polishing for microstructures, you use the diamond paste. So all those things, applications are there. When you want to go diamond like carbon and the high-end tools, the diamond coated tools are there. So this is a different type of application, but we will concentrate mainly onto the graphite. Now, as I told you, what is so important in this graphite is it is having a low density, where it is all the characteristics of graphite, it is having a chemically inert. You take the graphite particle or something, graphite block, put it into any acid, even including hydrofluoric acid, HF, nothing is going to happen. It is highly chemically inert and it is having a high thermal conductivity, electrical conductivity, low coefficient thermal expansion. It is a low coefficient of friction, like if you just touch it and self-lubricating. All the seals, whatever component made from the graphite, you don't require any extra lubricating oil, and it is biocompatible. Biocompatible means it does not react with the blood cells. So, but what makes it is very important is it can retain strength at high temperature. There is no other material in the whole periodic table which can retain strength at high temperature. This is the only material which is able to retain the strength. Now, these are the few applications of carbon in defense, like brake disc. I will show you the photographs of brake disc just to give you an example how this is so critical. Brake disc. You just imagine the weight of the aircraft, which is about 400 tons or 500 tons, and the speed at which it comes to runway. It comes around 700 to 800 km/h speed, and within a half a kilometer runway, it has to be stopped. The mass is known, half mv square. What will be the kinetic energy involved, and whole this energy will go only into the braking system. And the heat generated in this braking system is very, very high. There is no material which can withstand such type of heat other than carbon. So all the brake pads of aircraft is made out of carbon. The rocket nozzles, the nose tip of a missile. The missile, when it goes into the space and when it re-enters, the temperature encountered is around 2500 degrees centigrade. There is no material which can withstand to 2500 degrees centigrade. Now, this is the EMI shielding. Those who knows into the electronic side, what is the importance of EMI shielding? The all nuclear reactors. Now, looks to be simple. The nuclear reactors are the first wall of all nuclear reactors are made from graphite. So this can absorb, because of its structure, hexagonal structures, it can absorb the nuclear radiations very effectively. And the engineering application, suppose in your lab you want to press any material at 2000 degrees centigrade. You want to press some ceramic powder. The dye is used always a graphite. So all these things, dye and bolts, chemical application, all batteries, fuel cell application, those who are working, hydrogen storage, all this you will see carbon or the other derivative of carbon. The biomedical, the artificial heart valves in the Europe and other places, it is being used. Joints, adsorbent material, like as I told you, the activated carbon. When your engineers comes in servicing for water filter, it only changes the carbon black or carbon activated carbon. There is nothing other thing goes. So this is the adsorbent. The pencils, heat insulator, conductive base, sealing, all these things are there. Now here are the few photographs. This is the turbine plates. This is the graphite dye which we have used also. This all electrodes, graphite electrodes, which all metallurgical labs or like steel plants, the blast these furnaces, all furnaces are having this type of graphite electrodes. Apart from that, all paint industries is having a dyes and paints are also important. As I told you, the sports goods, the racket, the baseball, hockey stick, everything, the cycle, even the tire, the 50% or 60%, the ingredient is carbon black. The road on which we walk is also carbon, coal tar pitch. You see, looks to be very simple. The graphite bush, about hardly 5 rupees to 10 rupees the cost. But you will be surprised to know the total volume used all over the world is 5 billion rupees per year, only from this small component. So that's how this is inevitable for that. All industrial filters, water filters, suppose you want to remove your all effluent treatment, you require a highly porous. Now, we are also making highly porous graphite plates. As I told you, it is biocompatible. It can be fitted for lightweight composite materials, which will fit into the legs and ligaments, legs, all those things are there. And those who may be knowing, most of our face packs are having the charcoal and all those things are there, whether it is the joints in the bones or something, it is the carbon. Now, a small this thing will go into the little nano side. These are the carbon nanotubes. Now, theoretically, if you see any nano tubular seamless tube which is made out of carbon and size is nano, it is called carbon nanotubes. If it is a single layer, it is called single wall carbon nanotube. If it is having multi-layer, it is called multi-wall carbon nanotubes. Now, this to be one has to understand that if you just compare the size, the strength, the resilience, the conductivity, so all those things, because one of the best this thing is used like size or even the conductivity, people use copper wire, but you can see here the conductivity is very high, very high. So the strength, specific strength of this material is very, very high. Now, few applications like in electrochemical, all batteries you have seen, that is what when we say lithium ion battery. So lithium ion goes in where? The lithium ion goes in the host is graphite. It goes into the graphite, holds it, and then perform the charging discharging process. So even now people are using the graphite nanotubes, graphene now new development has come. This is for hydrogen storage, where the hydrogen can be stored. Of course, a lot of controversy, not controversial, a lot of variation of the result was there. So no consistency, because what is happening, the synthesis process decides the shape and morphology of the nanotubes. So the consistency, all groups have started reporting from 5 to 10 to even 0.25. So many governments have stopped this material, but this was for last 10 to 15 years back, this was one of the hot topics for hydrogen storage material. Now, this is another example for a carbon nanotubes. It can be act as a cantilever. It can be a carbon nanotube can be act as a host material to absorb the protein. like if you see, these are the probes in the your SCM or even the STM or even the TEM. Now, when we say SCM, nowadays people are talk about the field emission SCM. The field emission effect is coming only because of nanotubes. I will show you some of the slides on the field emission. So, which can give you a without any charging in a very thin shape, thin size is possible. Earlier, people were using different type of cathode material. Now they are having a different type of this thing which can emit the current at very sharp in a low voltage also. Now nanotung is a thing like when you look for any like beverages or even the tea, for example. Tea was like a black, red level tea, green level tea, yellow level tea. Who decides the level of green level or it is this thing? This is a different type of word. Earlier people manually it used to be done. A person was designated called tester who used to test the tea and then decide this particular flavor should come for this. Now this man is not required. One a nano tongue is there, nano electronic tongue, which will fulfill the purpose or the activity. So highly consistent. In electronic industries, this is used, which can be used as a carbonative. You can do a lot of experiments. This thing, it can be used as a actuators. You just pass these things, it will act as a actuators. As I told you, this is like a hollow man. This becomes invisible when you give a coating of a carbon nanotube. Have you ever thought of it that all our fighter planes are black in color? All civilian planes are not in any black in color. They are either silver or white when we go in Air India or any Indigo. But all fighter planes are black in color because they are given a coating which is having a gravitic particles which can absorb all the radiation, electromagnetic, not radiation, electromagnetic waves when it is passed through from a radar. It does not reflect back. If it does not reflect back, it becomes invisible. Now, these are the setup to make carbon nanotube. One is called arc discharge method, where the two graphite electrodes are taken and then passed to a stick, and you can get a deposit out of it. And you will get in this deposit only, you will get a lot of carbon nanotubes. This is a CVD method where you can grow nanotubes. This is another setup where you can pass underwater the graphitic electrodes and you can grow. This is laser ablation where the laser beam is passed on it to a graphite particle and graphite will get ablated and then deposit onto a copper cooled surface and you will get nanotubes. But not very popular in India because it is very expensive and the yield is very low. This is a fluidized bed reactor where the catalyst will fall because you require catalyst and a carbon containing source and from the bottom and you can get the high quantity of carbon nanotubes. And this is the setup which is used in mass production of carbon nanotube. Now once in CVD, the advantage of CVD is even though your quantity may not be there, but you have a very good control over the growth. You can grow into like a forest, you can grow like a pillar, you can grow like a leveler. All those things are possible in CVD. But in arc discharge, such type of flexibility is not there. You will get the carbon nanotubes into a bulk form, which is having a lot of graphitic particle also. So how to segregate is a big challenge. That is called purification of carbon nanotubes. You have to use the thermal, chemical, and mechanical process to clean it. And then once you are having this thing, you can get the very good quality of carbon nanotube. Now, when these nanotubes are purified, they have to be segregated in such a way that dispersion, otherwise you will lead to the agglomerates and agglomerates will settle down and it will not be useful for any application. You can see in the two bottles, the one bottle is having a completely settled down, nanotubes are there, other bottle is having a highly dispersed. Now, when it is a fully dispersed, then only it is having some application. Otherwise, it cannot be having any application. Now, some applications like as a sensor or electrical conductivity measurement or EMI shielding measurement, all those things was conducted. As I told you, when we have tried to develop or disperse this nanotube into a composite, you can just imagine top of that the two epoxy without any CNTs and even just 1% and completely epoxy becomes black plate. So with a low concentration, you can disperse the nanotubes in such a way that they can perform their performance because of unique properties. And one can we have done the composite. It is, you can see, it is highly dispersed. Now the difference between disperse and distribution is like this. They can be agglomerates, but people may feel it is highly dispersed, but dispersion requires from property transfer from one end to the other end. Then only it is dispersed, otherwise it is distributed. So all those things we have grown carbon nanotube onto the fiber, and this fiber was used in some composite. As I told you, this thermal, field emission effect, this is a carbon nanotubes which is having a very excellent field emission. Now, this is since it is in nano size, this is having a very large aspect ratio, atomically shorted and high temperature because of nature. Carbon is very highly temperature stable material, high electrical and thermal conductivity, because whenever any high anything is happening, but if it is conductive in very low, it will become charged and it will melt it. So the field emission properties are very, very important properties where the electrons and other things are at low voltage, it should pass through a current. Now you just see, earlier if you have seen that the television used to be very bulky from the backside because it was using the CRT cathode ray tube. Now we have a television very slim, very slim. All these things are possible because each particles can emit the current, and you don't require very ultra high voltage to get the high voltage. Only the high vacuum was required. Otherwise, normal 220 volt cannot give that type of emission. You have to have that to make use in 220 volt. You require a very high, ultra high vacuum. Then only it will emit the current. So that is called CRT, cathode ray tube. The name itself was cathode ray tube. Now this tunneling effect, all those things are the science. You leave it about that. The important point in this was the measurement of field emission effect. This was done for a defense application. Here we have observed the emission is very, very good when it is from the edge carbon. Now, if you use a single like a jungle, your edges are only on the corner. So what we did, we have used the laser subtly to give a different type of shapes. And then we found that when it is like this type of islands, the edges become more, because in each island you will have more, and then you get a very good emission. And this was done a very good result. We got it. Now you can see, of course, those who are in the field of electronics can appreciate more. At low voltage, also very high emission. We got it. Now we are working onto a very strong on carbon fiber field emitters. Now, if it is there in Japan, people are using this carbon-based powder and putting into a plastic film, a plastic sheet. Those are highly flexible, and you pass a current to become like a TV, flexible TV. Now here you can see here just one angle. Earlier in CRT, the face used to distort, but here it is not any issue. Up to 160 degree also you can get. Now coming to this carbon nanotube, there are variety of carbon nanotubes which is of a high order or a low order. Then when it is a high order, it is still the cost is very, very high. You might have heard about that carbon nanotubes are costing 1 gram few $100, and you also might have heard that people are telling we are using carbon nanotube few $100 per kilogram. So why so much of variation in the cost? Because of the quality. If it is a high quality, which is used only in the electronic industry, like transistor, interconnects, emitters, of course, the volume is very, very few quantities required. where you require a very high-end quantity in tons and tons. The nanotubes are not very high grade, but can be utilized like in a fluidized bed and for improving the properties. This is a graphite. We have taken a graphite flakes, intercalated it, and then exfoliated it, and then it becomes. You just see here the graphite flakes. Graphite flakes is chemically treated, and two particles have gone inside the layers, and then it is expanded by thermal shock. So it will become like a worm. Each graphite flakes will become like a worm, like our snake tablet in our Diwali day. And these worms are pressed without any binder. The graphite you might have seen, which is very rigid, very brittle, you cannot bend it. Now you see the pure graphite is flexible graphite. Now this is a technology was developed and various products were developed from this technology. The gaskets, the boards, the seals, the VAP means wheel and axle plant for railway, and the bipolar plate for the fuel cell. Now you see, looks to be gasket, looks to be few examples I will show you. Looks to be very simple. But can you touch the silencer after running of operation of 1 hour of automobile running? No, the heat is there. The heat is coming from the engine. Now engine is very, very hot. Now you just imagine the material which can give the pressure, sustain the pressure leakage, and then at high temperature. Now most of the materials are used for low temperature like rubber and other things. But this is the material which is used at high temperature for different for gasket application. Now wheel and axle plant. This is the wheel is casted in such a furnace where this is the wheel here in the top. So molten metal will pass through and then be joined. Here each time people were using earlier the asbestos gasket, then they found that lot of carcinogenic effect comes, lot of health issues comes. Then it is not a recommended material. They were looking for an alternative material. This material was developed for them. Now, if you see, this is a graphite evaporation boat. Evaporation boat is used for evaporation of aluminium. Now, this aluminium is given into the all uncle tapes everywhere. Why have you observed why this chips packets are having a silver foil inside or a aluminum foil inside? Because 90% plastics are not food grade plastic. You cannot store any food. So they have been given a lining so that all food products will retain their food this thing, otherwise it becomes like a non-eatable. So this earlier people were using the aluminum foil and the plastic foil and then rolling it. So it used to be around 80 microns. But then just by evaporation technique, about 3 to 4 microns of this thing was used aluminum. Now this is a bipolar plate into a fuel cell. The one side the channels will pass through the hydrogen, other side will pass through the oxygen. So each plate will act as like a anode for one cell and cathode for other cell. And that's why it is called bipolar plate. So this is a stack of a many cells, and that's why each plate will act as an anode or cathode for the nearby cells. And this is a cell assembly. So this is our Chennai center people are using it. Another important applications of this graphite is in oil absorption. Oil spill is very common in many places, knowingly, unknowingly, it happens. And it leads to a lot of marine birds and other things, mammals are getting affected, which is not good. So this porous carbon, you have seen that it is having a high pores. These pores will act as a capillary, and then all oils can be whatever onto the surface will absorb, and then you can recover back around 78 to 80 ml per gram oils can be taken up from this. And for this we are having, and you can recover back the oil, and yes, I was holding a patent for this. Now, as I told you, these are the some working models, how it can be used into the real applications. Now it comes to a graphene. Graphene is a material which is in the last 3-4 years, it is very actively people are using a single layer graphene because of its exotic properties. So we have not used like a chemical CVD process, we have, but we are using the same accelerated graphite concept. When it is intercalated, the single layers can be get it. So we could able to segregate the few layers and like it is having a few thousands of layers. Now we have reduced to about less than 10 layers and less than 10 layers internationally it is called graphene material. Not 10 is the limit. Like any material is called nanomaterial when it is having a size about 100 nanometer. More than 100 nanometer does not come under the nano category. So we have used this graphite plates and made into a paper through a vacuum filtration. So this is the graphite and which will be found that many layers can be segregated. Now if you go for a different type of filtration process, you can get from 3 layers to 7 layers to 16 layers to 29 layers depending on your segregation process. Now these all graphites are has to be characterized very effectively, whether it is in a Raman or XRD or anything. So very high-end sophisticated equipments are required. Otherwise, everything in carbon field, unless you know the characterization very effective on carbon looks black, you cannot differentiate between carbon black and carbon nanotube by apparent way. Everything looks powder. So now, whether it is a carbon nanotube or a graphene or a carbon black or any other material, acid clean carbon or anything or graphitic powder, you should able to understand what type of characterization technique it is having. Now this graphene or materials can be made from hydrophobic to hydrophilic just by a treatment. So you can play with the chemistry of this material by changing into hydrophobic to hydrophilic, and depending on the applications, like 67 angle of contact has been changed into 109. So from hydrophilic to hydrophobic. So you can always play with the chemistry of these particles. This technology is being transferred to one industry, and that industry is working in our incubator. ARCI is having an incubator. Now that has been, because for initial period about 9-10 years it has worked. Now they have taken their own land, they are working. So this technology was visited by Dr. Kalam, Professor Ramarao, and many more. Oh, this is already I have told you. So thank you very much. All those things are there. If any questions are there, I will use the phone because I'm not able to hear the sound. Anything is there, and as I told you, the purpose of this is whatever we know is very limited, and whatever is there unknown is very more things are unknown to us. Okay, and people can note down my contact details. If any doubts are there, they can always be in touch with me, and through either the host faculty or they can directly in touch. But I may not able to respond it immediately because many times I have some other commitment. But definitely, whatever way I will try to help you, I will try to help. If anybody wants to visit or something, just write to our HR department. We can coordinate their visit also. If I think if is there anything, we can take up few questions if any questions are there.
Dear participants, if you have any questions, you can.
No, if any questions are there, you just so. Any questions are there? We have good setup of presentation. So there is no problem. And this is my home laptop. I think I said it's a old one or something. I'm very sorry for the inconvenience people have faced. But if anything is there, they can put forward the questions, or then you can take those questions, make them into a full listing, and if anything is there, you just forward it to me.
Sure, sir. We'll take the questions and mail to you, sir.
Yeah, that would be great. Yeah. Anyway, once again, very sorry for the inconvenience because very rarely it happens
No, sir.
that through mobile you people are hearing it. Okay. Right. So, okay. Thank you.
Thank you so much for your valuable session, sir. Thank you so much.
Thank you.
Sir, I am audible.
Yes, sir, you're audible.
Okay, sir. So we are delighted to invite you on this session.
Shall I share the
Yeah,
content, sir?
sir. Yes, yeah, you can share the screens.
Sure. Sir, is the content visible?
Yeah, it's visible, sir,
Okay.
and audible also.
Yeah, sure. One second. Okay, is the slide movement visible, sir? Slide movement?
Yes, sir. It's visible, sir.
Fine, sir. Okay, fine. Okay. Good evening, all. It gives me pleasure to be a part of this FDP program. So I will be focusing on the topic sustainable manufacturing. So as we all know, manufacturing domain has undergone tremendous changes in line with the industrial developments. And sustainable manufacturing is one such vital manufacturing system which organizations adopt to develop environmentally friendlier products, process, and also to deal with initiatives to minimize environmental impact. So in my lecture, I'll be focusing on the fundamental concepts of sustainable manufacturing, tools and techniques of sustainable manufacturing, in what way sustainable manufacturing could help the present industrial developments in terms of sustainable additive manufacturing, sustainable and smart manufacturing. And towards the end, we shall discuss the scope of sustainable manufacturing from viewpoint of the present industrial developments. So let me just proceed with the concepts. And all attendees, any queries you have, you can feel free to unmute and ask me. Interimly, let us discuss and take ahead. Also, you may post your queries in the chat box. If you look at the definition for sustainability, the most commonly accepted definition comes from UN Brundtland Commission's definition, which states sustainability as meeting the needs of the present without compromising the ability of future generations to meet their own needs. So the key inference from this definition is that resources have to be utilized very optimally, thereby the environmental impacts could be minimized, and the system and the ecological balance could be ensured. The interesting aspect to understand the concept of sustainability is that one of the prerequisites for implementing sustainability or sustainable manufacturing paradigm is lean system, where the focus is to minimize, eliminate waste. Thereby, we streamline the process and purely we produce to customer demand. So, such lean system has the perspective for sustainability, where we are producing only to customer demand and we are utilizing the resources only based on need. So, such inference will help us to better understand a sustainable system. So the commonly known terms of sustainability include environmental sustainability, economic and societal sustainability. These are the three vital dimensions of sustainability or sustainable manufacturing, and which is widely called triple bottom line approach for sustainability. So here, if we look at the dimensions of sustainability, the triple bottom line dimensions of sustainability, as we discussed, it has like environment, economy, and societal dimensions, which deals with which correlates with the three P's, like protecting the planet, ensuring economic prosperity, and also taking care of the societal development in terms of the.
The screen is visible, sir.
Yes, sir. I'm proceeding. Okay. So this triple bottom line dimensions of sustainability, which we discussed, like environment, economy, and society, which takes care of protecting the planet, ensuring economic prosperity, and also take care of the requirements of individuals and the organizations as whole. The environment dimensions focus on cleaner resources and ensuring ecological balance and implementation of regulations, legal policies, and so on. Economic dimension provides new employment opportunities, ensure product and process innovation, and enable business opportunities even at a larger scale. And societal dimension focus on improved health, ensuring safer workplace, take care of the workplace and the worker safety, and enhance the quality of life and ethical aspects. These three dimensions of sustainability are interconnected, and any initiative in one dimension will have its corresponding improvements in other two dimensions naturally. Let us discuss an example for this triple bottom dimensions of sustainability. So we are seeing like two scenarios. One is economy as acting as a driver, another one is society is acting as a driver. Wherein when we keep the objective of the reducing the cost of a product, thereby the profitability has to be enhanced from economical perspective. Naturally, we go for weight reduction initiatives. Many industrial organizations constantly they work on reducing the weight of the product. So once we reduce the weight through appropriate approaches and optimization methods, then naturally the environmental impact also gets minimized. And from societal perspective, it creates new business opportunities and it creates new type of it inculcate new types of skills among the workforce, and that will contribute to the profitability improvement through cost reduction. So here it is obvious that an initiative we take from one dimension will have its corresponding improvements it brings about in other two dimensions as well. Likewise, we can take from the objective from any perspective, one perspective, and we will be able to correlate with other two perspectives. It's more interesting to see this connectivity between the three dimensions of sustainability. Next, moving ahead, the sustainable development, we could see there are like different domains wherein the sustainability concept is being employed. One is obvious with manufacturing. Then we do have like a transportation, agriculture, then construction, infrastructure, energy domain, and the applications are expanding day by day. Again, we can see at the core part, the three dimensions have the connectivity, environment, economy, and society, and technology act as a base for which always we should go ahead with promoting the creative and innovative thoughts. That creative and innovative skills need to be inculcated, for which education and training is also equally essential. So this will help us to bring about the thought process for sustainable development, because for any initiative we do in the context of sustainability, naturally, though there are certain methods and procedures that innovative mindset and bringing about the improvements and continuous improvement initiatives are also very, very essential in this context. So if you look about the alternative terms for sustainable manufacturing, also it is referred as environmentally responsible manufacturing, as it protects the environment through various methods and procedures, and also called environmentally benign or environmentally inclined manufacturing. It's also referred cleaner process in the context as green manufacturing. Let us discuss after some time the difference between green and sustainable manufacturing. It's also referred economically advantageous manufacturing, like lean manufacturing, where the focus is to reduce waste and enhance the value from customer's perspective and producing to customer demand, so on. It's also called energy efficient manufacturing, where the focus is to optimally utilize energy as per the requirement, as per the need, process need. Energy has to be provided, energy has to be utilized. And also exploring renewable sources of energy and utilizing them, which is a very important initiative which industries constantly take ahead. This gives certain perspective on the terms and definitions of sustainable manufacturing. If we look about the basic elements of sustainable manufacturing, or what kind of expectations we have with reference to a sustainable manufacturing system, one is to reduce energy consumption and energy utilization. Energy utilization has to be optimal. Then reducing waste, different forms of waste, and ensuring the yield, process yield, reducing material utilization, because materials have to be utilized as per the requirement, and how to enhance the durability of products, how the operational safety could be enhanced, how health hazards could be reduced and health conditions could be improved upon, and consistent improvement of quality in manufacturing process have to be ensured, and improved reuse, recycling, and remanufacturing of products. All these are very, very important. I will discuss gradually about the significance of various R's in sustainable manufacturing, and try to maximize the sustainable sources of renewable energy. And we need to explore the ways and means to utilize the renewable sources of energy. These dimensions gives us the elements, the core elements, or the expectations with reference to a sustainable manufacturing system. Also, sustainable manufacturing is referred as paradigm E, because if you see most of the dimensions, they start with the letter E, like ecology, environment, energy, economy, employment opportunities, empowering the workforce. Because once the creativity and innovative thought has to be inculcated, then naturally we need to empower the workforce. It's equally important. Education. So continuous education and training is very essential. And excellence in manufacturing. If you see all these, the dimensions of a sustainable manufacturing system, naturally they start with the letter E. That's the reason the paradigm of sustainable manufacturing is referred or popularly called paradigm E. Next, the evolution of sustainable manufacturing need to be understood, wherein we can see over the time frame and the stakeholder value is increasing over the time frame. From traditional manufacturing, the lean manufacturing has taken over, which is waste reduction and waste elimination system. From lean manufacturing, we move towards green manufacturing, which is environmentally benign or environmentally inclined manufacturing, which is 3R based, basic 3Rs, like reduced use of resources, reusing, and recycling. Next comes sustainable manufacturing, which is an innovative manufacturing paradigm, which is 6R based, where other 3Rs also come into picture, like recovery, reverse designing, reverse manufacturing. These additional 3Rs are also being incorporated in a sustainable manufacturing system. So this slide gives a perspective of the differences between green manufacturing system and sustainable manufacturing system, because we come across these two terms alternatively. They do have certain similar focus, but they do have subtle difference. That difference is being discussed in the context of evolution of sustainable manufacturing. This slide shows the complete tools for eco-efficient or sustainable manufacturing, starting from an environmental management system, product design and development, with the focus on minimizing environmental impacts, designing for environment, which has a set of guidelines, set of thumb rules for designing the products from viewpoint of environment, eco-efficiency analysis, life cycle assessment, which is a powerful tool of sustainable manufacturing, which is aimed at examining the environmental impacts associated with the products and process. We do have environmental supply chain management, strategies of green procurement, corporate environmental reporting, life cycle costing, and environmental impact assessment. So there are like different tools. In this presentation, I'll be focusing on the discussion on two important tools. One is like life cycle assessment, other is like life cycle costing, and how they help in terms of making the process and product more sustainable. Okay. This slide shows a typical model for sustainable product development, where on the left side, we could see the traditional development, which starts with the customer's requirements, and we proceed with the design object goals. We move ahead with the design, we manufacture, we use the product, and finally, we dispose of. It becomes like a landfill. But on the right side, we could see the sustainable product development in terms of developing a modified form of quality function deployment, which is called environmentally conscious quality function deployment, which considers both the environmental and the traditional requirements and develop the trade-off model and execute a basic LCA and proceed with manufacturing, usage, and finally, before disposing the products, the key decision has to be made whether to reuse the components or recycle or dispose them as landfill. But this kind of a decision is very, very essential before we go ahead with the disposal. Because the ultimate objective is that the landfill creates more impacts. Naturally, it has to be reduced. So in this context, the decision of what kind of end-of-life aspect the product has to be subjected to need to be clarified. That's the reason these decisions of whether reusing or recycling or disposing the product has to be explored and the key decision has to be made. Okay. So before we proceed with the life cycle assessment, so at this stage, are there any queries from the participants? Since we covered some fundamental aspects of sustainable manufacturing, are there any queries at this stage?
Yeah, any questions you can ask. Dear participant, you can ask if you have any questions.
Kindly feel free to ask questions. Fine. Let us proceed further, and if you have questions interimly also, you may post in the chat box. And so as we discussed about the concept of the sustainable product development, it clearly shows the contrast of how we sustainably develop the product when compared with the traditional product development. So in this context, a modified form of quality function deployment will be used and very systematically will be able to identify the metrics which have good potential or significant potential for sustainability. Though there are like several engineering metrics in terms of designing and developing products, the key engineering metrics could be identified. And also in a product assembly, which components have the potential for reusing and recycling could be identified. And this a combination of the engineering metrics, the vital engineering metrics, and the vital components, the mapping could be established. And the mapping could mapped relationship could be further deployed to bring about sustainability in terms of designing and developing products. So that's very interesting to take ahead with such an approach for product development. Okay, as I mentioned, life cycle assessment is a very essential tool in the context of sustainable manufacturing, as it helps us to assess the environmental impacts very systematically and to identify the potential for minimizing the environmental impacts to a greater extent. So here, in the context of LCA, I typically will be following an SITAC approach, which is called like Society of Toxicology and Chemistry, they devised a 4-phase approach for life cycle assessment to typically calculate the environmental impacts of a product from design through manufacturing, further to the use and to end of life, covering the material aspects as well. So this life cycle assessment is a powerful tool, which is also called life cycle analysis. It's also called eco-balance or cradle to grave analysis, which will help us to examine the environmental impacts associated with various stages of a product life cycle, starting from materials phase, which includes like materials extraction and materials processing, manufacturing, and distribution, use, and repair, and further like maintenance and disposal of products. So here we'll be doing life cycle assessment as per the standard. Based on standards, we'll be referring and we'll perform life cycle assessment, because that will help us to ensure the inferences are irrelevant, and also will help us to benchmark the products and process in terms of these environmental measures. So for performing LCA, we'll be referring like two standards as a part of the environmental management system. One is ISO 14040, which contains the principles and frameworks for performing LCA. And we do have ISO 14044, which includes like requirements and guidelines for performing LCA. So these standards we refer for performing a life cycle assessment. This is a list of the environmental impacts we can determine through LCA studies. Any LCA study, when we perform, 16 environmental impacts we'll be able to find. But from viewpoint of product design and manufacturing, 4 impacts are highly significant, and most of the studies, we refer those 4 impacts. One is carbon-based impacts, another is sulfur-based impacts, third is nitrous impact or the phosphor impact, and energy-based impacts. These are very significant in the context of the general product design and manufacturing we do. So in a nutshell, these 4 phases of LCA include goal and scope definition, inventory analysis, impact assessment, and interpretation. These 4 phases have to be done very systematically to determine the environmental impacts. So in goal and scope definition, we try to understand the context of doing LCA. Why we do LCA? What are the goals for performing LCA? And what are the questions we should answer at this stage? And it will help us to establish the scope for performing the LCA and also the necessary details that are required for performing LCA. So here, once the goal is being set, say for example, the customer may ask the details of LCA study, or the regulatory agency, or maybe as a part of sustainability reporting, we may perform LCA. So here, once we have understood the goal, next we need to set the boundary of the system. Are we going to do for the entire life cycle phases, or for a particular life cycle phase, like only during manufacturing, or starting from manufacturing to end of life, even including the materials phase? That should be made clear. The boundary should be established, and the product functionality has to be understood. It's also called like overall product function, referred as a system function, which is the intended purpose of the product under the environmental impact analysis. And also we should be clear with the functional unit. Once we understood the function, we do have like primary, secondary, and tertiary functions as a part of the functional modeling. We need to understand what is the functionality of a product, or maybe like the functional unit. Say, for example, in the case of a coffee grinder, which chops the coffee pellets, the function is to chop the coffee pellets, and the functional unit is nothing but per hour, how much coffee pellets are being ground, or maybe like per day, how much coffee pellets are being ground. That forms the functional unit. So once we understood this, once we set the goal, we set the boundary, and we understood the functional ality and the functional unit. Next phase is to perform life cycle inventory analysis. Here, the term inventory is having slightly different synonym. So generally, inventory means the stock of goods, the stock of products, and here inventory means the kind of inflows which is happening from the system onto the system. So here, on the input side, we need to provide like materials, we need to provide energy, we need to provide like auxiliary materials, coolants, and so on. And on the other side, the output side, we do have the product, and also we do have like emissions or the impacts which are being sent to the nature. So here typically we need to establish a flow model. Typically a process modeling we should do, just connecting the inputs and outputs and how it is related with the impacts. This is very much essential. And this inventory data we need to collect and we need to provide, and we need to establish a process model for performing life cycle assessment study. The third phase is impact assessment. As LCA, for performing LCA studies, the LCA databases are available in the software interfaces which perform LCA. So in the database, already for the various process, the relation between the inputs and outputs and impacts are being defined. So once we provide the inventory data, the interface, the software module calculates the impacts through once we specify the particular impact assessment method. So here, important activities in impact assessment phase is selecting the impact categories, like whether we are focusing on health related or environment related impacts or like society based impacts, and also the indicators. And we define the inventory parameters. The inventory parameters are being assigned to the impact categories. And once we specify the data, the impacts will be computed. And accordingly, the inferences could be derived. Next comes the interpretation or the inferences, wherein the typical phase. Also, another important aspect in impact assessment is that we need to specify the impact assessment method, because in the context of Europe, the impact assessment method may be different. They may follow like CML. In the context of Indian studies, we follow eco indicator. Likewise, the impact assessment method also have to be specified, because this LCA data or location based, location is also another important aspect. And the inventory impact assessment method varies from one geographical location to the other. The fourth phase is interpretation. So once we have done all three phases, once we found the environmental impacts, next we need to explore how we can minimize the environmental impacts. What are all the ways and means to reduce the environmental impacts? Generally, in the context of manufacturing, we may explore like alternative materials or alternative product designs. We may try to optimize the designs, and also like alternative process and changing some process sequence in terms of like exploring alternative process scenarios, process sequences. That also we explore. And ultimately, we need to take all possible efforts to minimize the environmental impacts. So in a typical LCA study, we go ahead with like goal and scope definition, then inventory analysis, impact assessment, and finally interpretation. So the benefits of performing LCA study is to identify the environmental impacts, explore the opportunities to improve the environmental impacts, and to comply with the regulatory agencies' norms, and try to integrate environmental management into the decision-making process, which is equally important. So, life cycle assessment modules I'll be discussing a little later. So now you might have got a perspective of why we do LCA. In life cycle assessment also, there are like two types of LCA we do. One is product-based life cycle assessment, another one is process-based life cycle assessment. Just after discussing on life cycle costing, we will proceed and I will show the procedure, how we do a product-based LCA and process-based LCA also. Now we shall go through the second tool, very important tool of sustainable manufacturing, which is called like life cycle costing. Here, typically what we try to do in a product assembly, we do have like different components. We need to find that which component has the significant potential for reducing environmental impacts. Because all components may not have the equal potential for minimizing the environmental impacts. So here, a cost model is being developed, which can integrate the production cost and environmental cost. Also, it has the technical status of a product is also another important factor. So typically, we'll be calculating the product gain, which marks the difference between the product value and the life cycle cost. So the life cycle cost, in the sense, it includes both product cost and environmental cost. And generally, the technical context of a product, which has the potential for this reverse processing, is referred as product effectiveness. And the environmental cost is generally set as 10% of product cost for forward manufacturing, and it's for 1% for the reverse manufacturing. Let us go through the analogy. Let us not go deep into the mathematics, but just I'll explain the procedure, how we compare two scenarios in the life cycle costing. First scenario is nothing but here you could see all the cost categories will form the rows, and the components of a product assembly will form the columns. So typically, there are two scenarios. One is producing a new component, another one is like reverse manufacturing a old component. In terms of producing a new component, we know the product cost. And as I mentioned, the environmental cost is being set as 10% of product cost. It's a thumb rule to be followed. And the life cycle cost is sum of these two. And market price is known. And the product effectiveness takes 1 if it is the component has potential for reuse or reverse manufacturing, or 0 otherwise. And product value is the product of product market price and product effectiveness. Then the product gain is the difference between the product value and the life cycle cost. We compute product gain for all components from this forward manufacturing scenario. Next, we proceed with reverse manufacturing the component. So in reverse manufacturing, we will incur certain procurement cost, and also we'll have some reverse manufacturing cost for reverse processing activities. Then environmental cost is set as 1% of reverse manufacturing. The sum of these three will mark the product life cycle cost. Similarly, we know the market price and product effectiveness. We calculate product value. The product gain is the difference between the product value and the product life cycle cost. Now we calculate net product gain, which is the difference between the product gain for reverse manufacturing an old component, by that of the forward manufacturing a new component. So we know the net product gain. In the net product gain, naturally, it should be positive if the component has the potential for this reverse processing. And whichever component having the highest potential for reverse processing will have higher positive values. So now this scope of this tool is that for different components, we'll be able to find out in a product assembly which component has very good potential for reuse and this reverse processing. This is something like a very important task we need to do in order to find the potential of a component for this reverse processing activities. It's a very significant tool which will help us to find the potential of a component for the reverse processing activities. Fine. This slide shows the kind of the results of the sustainability analysis from a product perspective. Here we do have like different impact parameters, as I mentioned, like carbon impacts, sulfur-based impacts, nitrous impacts, and energy consumption, energy-based impacts. Here through this product-based LCA module, we'll be able to find out the environmental impacts across the life cycle phases, like materials, manufacturing, use, and end of life. Okay, so what kind of data I should provide is that the geometric model of the product should be one of the input, and also what material the component is made of, and what is the typical manufacturing process, and also the locational data in terms of where the component is manufactured and where it is going to be used. Then the module calculates the environmental impacts across the life cycle phases of the product. And it is more interesting to compute the impacts. All these we are able to do during the early phases of product development, early design phases we are able to do. And also we can compare the designs. Say, for example, we can do a very good combination among these three entities of sustainability, like material, product, and process. Say, for example, here this slide shows when the material and process remain same. For two different product designs, the environmental impacts are compared. Green is for an optimized design and the black one is for the existing design. So the two designs could be compared with the same process and with the same material. Which one is having the lesser environmental impacts? We are able to find out. This is nothing but a typical product-based life cycle assessment study, wherein during early phase of design, we are able to find out the environmental impacts associated with the products. Very interesting study through which we'll be able to. Similarly, we can try for keeping the design and material same with the two different process alternatives we can do. Similar task we can do for two different materials as well. That's the essence of this product-based LCA study. So till now, we covered the concepts of sustainable manufacturing and also the insights for sustainable product development. And we discussed on life cycle assessment, the four important phases of doing LCA study, and life cycle costing, which will help us to identify the component having the potential for reuse and this reverse processing activities. And also I've shown the perspective of product-based life cycle assessment. So before we go ahead with the other connective concepts, are there any queries from participants to this stage? Participants, are there any queries?
You can ask questions, dear participants.
Sir, are there any queries related to my lecture in the chat box?
Yeah, just there is one question, sir. Just a minute, I am reading the question.
Yeah, please.
So how does sustainability influence the product life cycle from design to disposal?
Okay.
So
So
from
here,
the previous slides, I think.
yeah, fine. Okay, I got the question. So here, the very important aspect is that the environmental impacts have to be assessed in order to make the product more sustainable. That's the reason we take across the life cycle phases, starting from materials manufacturing, use, and end of life. And typically, we perform a life cycle assessment study to find the environmental impacts. And also through a product-based LCA, we'll be able to quantify the environmental impacts across the life cycle phases. The different impacts, the four impacts we can quantify so that we can take all possible initiatives to minimize the impact. Say, for example, the carbon-based impacts I need to reduce. Then I can explore alternative design, or maybe like I can explore alternative material process with different combinations we can try in order to reduce the environmental impacts. Thereby, we try to make the product sustainable across the life cycle phases. Okay. And so are there any further queries in the chat box?
Another question, sir.
Yes.
So, what are the major challenges faced in implementing the sustainable product development?
Fine. So the major challenge is that the kind of the insights for sustainable product development and the need for sustainable product development has to be conveyed very appropriately. And the second aspect is that we need to identify the appropriate methods or procedures in the context of deploying, developing sustainable products, and certain training programs and also like skill-based programs need to be conducted from viewpoint of inculcating the thought for the sustainable manufacturing. And overall, we should bring about the involvement and the passion towards developing sustainable products. So such a culture, bringing about a culture is also an equally important challenge. So for which like a lean system, if it had been implemented in the organization very meticulously, that also forms the pathway for implementing sustainable manufacturing. Right. Sir, are there any queries?
That's it, sir.
Fine, sir.
Okay, sir.
Fine, sir. Let us proceed and let us take intermediate queries.
Yes.
Okay. So now let us spend some time on discussing about the basic 3 Rs and further 3 Rs for sustainable manufacturing, which is popularly called 3 Rs and 6 Rs of sustainable manufacturing. So the fundamental 3 Rs are like reducing the usage of resources, then exploring the reuse potential, then recycling potential. Then the additional 3 Rs includes a recovery, to what extent we are able to recover the components from an assembly after the useful lifetime is over. Then also about like reverse design and reverse manufacturing. These additional 3 Rs also equally important. So a green system has basic 3 Rs. A sustainable system has basic 3 Rs plus the advanced 3 Rs. So this 3 Rs and 6R concept is being depicted in this slide, wherein from a typical ecosystem, we take the material, energy, then we extract the materials, we process them, we manufacture them, we put into use, and we should not dispose as such. We need to, once the product lifetime is over, we need to treat them, dispose them. Then comes this 6Rs, 3Rs and 6Rs. We need to adopt a particular reverse processing method, treat them. Then again, we can send back. So thereby we can try to minimize the waste and emissions, and the ecological system could be in balance. So identifying an appropriate end of life method for a component is a very key decision which need to be taken utmost care. That will help us to develop the sustainable products in a more effective way. The material flow and the interaction in the context of 6Rs is being shown. Whereas implementing, as I mentioned, implementing lean system will help us to reduce the usage of resources purely based on need, purely based on customers' requirement. We are working. Then comes the role of reusing, recycling. Then we go ahead with the other 3Rs like recovery, reverse design, and reverse manufacturing. And once the product is being subjected to any of the EOL methods, then it can be disposed of safely. We need to utilize the ways and means to the product could be taken ahead before it is being sent back to the environment. This 3Rs and 6Rs, they help a lot in terms of making the product and process sustainable. Next, let us spend some time on discussing about energy efficiency analysis of manufacturing process. Typically here, in order to minimize the energy consumption, we need to develop the energy models and also detailed process models we need to create. So generally, in the context of manufacturing, we may develop a two-dimensional process model, correlating the inputs and outputs. We call it as an IO model, inputs and outputs. But in the context of sustainability, we need to go for a three-dimensional process modeling, like the relation between the inputs, outputs, and impacts. IOI modeling is very essential. So on the input side, definitely we have metal-related information, geometry-related information, and also like the information related to the auxiliary materials and coolants. Then once they are being provided to the subjected as an input to the process, we get in terms of on the output side, we get the product and also the waste and emissions. So here we need to take all possible efforts to minimize the waste and emissions. And the product has to be the product yield we need to ensure, because there's a defined relationship between the inputs and outputs. And the relation between the calculated yield is being established. So is the process yield as per this theoretical calculations? Or is there any deviation we need to analyze? And here we need to go for a typical process modeling to find the environmental impacts. And now in the context of smart manufacturing system and all, we even go for higher order process modeling system, whereby the technologies will augment the process. And accordingly, that will help us to make the process more energy efficient. It is possible through technology integration. So there are like 4 levels of energy efficiency assessment, which starts with the typical process level. And from process, we move ahead with the machine level, because a typical machine has a set of process. Then from machine level, we go to the line level. So a line will have different machine tools. And from line level, we go to factory level, because a factory will have multiple lines. So we start with a process. We move to the machine level assessment. Next, we go to the product line or the assembly line level assessment. Then we go to the factory level or organizational wide assessment. And that is how the energy efficiency analysis has to be conducted. So now let us, as I have shown earlier also, this product-based LCA video, which can be done using this Sustainability Express product tool, which comes as a part of SolidWorks module. These are the 4 environmental impacts which are very much important in the context of product design and development. One is accounts for carbon impacts, second for phosphor impacts, third for sulfur impacts, and the fourth is related to energy impacts. These 4 impacts are very, very relevant in the context of product manufacturing. This is something like an interface of this product-based LCA, how it look like. So the first essential input is nothing but the geometric model or the CAD model of the part or component. Then we need to specify the material. Then the manufacturing process. Then we need to specify the manufacturer and user location, where the part is getting manufactured, where it is going to be used. Because the locational information is also equally important, because the LCA standards are different for different locations. Once we specify this, we can see a pie chart which gets generated, which shows the environmental impacts across these 4 categories across this environmental impacts. Now we can explore the possibility of changing the material, and accordingly we can see the reflection in terms of the environmental impacts, the improvements in terms of the environmental impacts that we can monitor. This across the life cycle phases will be able to calculate. So that a customer asks, what is the carbon footprint of a product during manufacturing phase? We'll be able to very clearly say, for which we need to perform a typical LCA study. It's very essential, and we are able to compare the impacts across the life cycle phases. It's a very effective tool which will help us to find the environmental impacts during early phases of designing and development. That is very, very essential. Fine. Similarly, we do have like process-based life cycle assessment, where we'll be able to find the environmental impacts associated with the process. So for which there are like 2 different modules they are widely used. One is called GABI, another one is called like a SIMAPRO. The LCA modules which are widely used in industries and R&D establishments. So this is the interface of the SIMAPRO module, LCA module, where you could see on the left side, it is totally based on the ISO standards. The 4 phases of an LCA, starting from goal and scope definition, then inventory analysis, impact assessment, and interpretation. So here we'll be able to, this interface is very easier to adopt because we will not miss any of the steps in the interface. So step by step, we try to proceed across the phases and we'll be able to determine the impact. Say, for example, I'll be able to show you a typical case where we found the manufacturing process and the environmental impact of the process, the manufacture of an automotive component. So there's nothing but the interface of the LCA module, where we could see, again, it is based on the ISO standard, LCA standard. And we need to define the process stages, and we need to define the inventory data for the process stages. Then once it is being defined, then the inventory data will be correlated with a database where it contains the defined relation between the inputs and outputs and the impacts. Then we need to specify the impact assessment method. So in the context of Indian scenario, we'll be adopting eco-indicator method. Once we specify, then it will find the environmental impacts across the life cycle phases. And for different process, we can see the impacts being generated for different phases. There are like 3 colors which are being used. One, the red is for related to health-related impacts. Green is nothing but ecosystem-based impacts. Yellow color shows resource-based impacts. Here I'll be able to know for a typical process which impact is more. And also, we'll be able to consolidate all the impacts. We can normalize them because every impact will be in its own unit. We can normalize and we can come out with a very unique cumulative impacts also could be calculated. So this logics and the computational models are available through which we'll be able to calculate the total environmental impact of a product. It will be in a common neutral score into neutral unit called points. But for smaller impacts, it will be represented using millipoints. So here I can compare 2 different automotive products in terms of their environmental impacts. It's possible. And this interface is also like very easier to adapt And it has very good scope for even like water footprint assessment and air footprint assessment. Like variety of LCA studies could be performed in this module. Fine. So now we have discussed about the modules. One is a product-based LCA module, and another one is process-based LCA module. Now let us spend some time on discussing about what is the significance of the sustainability concept with regard to additive manufacturing. Because we know like additive manufacturing is a key technology, which even in the context of the present industrial revolution, which is called Industry 4.0, it's a technology which takes a lead uh, in replacing many of the traditional manufacturing process technologies. So additive manufacturing is more interesting to explore the concept of sustainability with regard to additive manufacturing, because additive manufacturing already it has certain inherently sustainable aspects. Say, if you say in additive manufacturing, we do have the concept of primary materials or like model materials, and we do have like support structures. Say maybe like in a polymerization process or in a metal extrusion process. The support structures, how much support structure I should provide? Because we should not provide more support structures than the necessity. So how optimally we could provide the support structures is equally important. And also in the context of powder bed fusion process, where we use the powders, earlier there were no mechanisms available for reprocessing the powders. But presently, there are mechanisms which are available for reprocessing, reusing, and recycling the powders. And the material deposition parts which are being created during slicing, and also even in the extrusion type additive manufacturing. So there exists provision for optimizing the printing path, and also the possibility of the material reduction also could be explored. And this kind of typical LCA studies, which I have shown like process-based LCA, could be very well adapted. And we'll be able to compare the environmental impacts, which is produced for a polymer part through this extrusion type additive manufacturing when compared with the traditional blow molding. We can create the process models and we'll be able to compare the environmental impacts with the two processes, and we can find which is more sustainable. Similarly, let us take any metal additive manufacturing and we can compare with this equivalent traditional technology, and we'll be able to benchmark them from viewpoint of sustainability. And also in additive manufacturing, we do have like designing for additive manufacturing, which is called like DFAM, wherein we try to make the product design which is more compatible for additive manufacturing. So even in the context of DFAM, many of the sustainability concepts could be explored. Even like product-based LCA also could be initiated, could be done. Thereby, we can take all possible efforts to minimize the environmental impacts of the product during early design phases. That's very, very essential. Even now, we are moving towards like a 4-dimensional additive manufacturing. From like 3D printing or 3-dimensional additive manufacturing, now we are moving towards like 4-dimensional additive manufacturing, wherein we are trying to utilize like smart materials, shape memory materials, shape memory polymers, so that the components, once they are being printed, they will get self-assembled and they become a final assembly. So these kind of technological developments also necessitate the adoption of these sustainable concepts and utilizing the sustainable concepts. Thereby, we can try to make the process more sustainable and more smarter as well. So since we have come across this term like smart manufacturing in the context of sustainability, let us spend few minutes for discussing about the concept of smart manufacturing. But prior to that, are there any queries from participants? Kindly feel free to ask questions.
Participants, you can ask questions. if you have.
Sir, are there any queries in chat box? Further queries?
No, sir, up to now. So
Fine,
if there are any questions, I will.
Yeah, please. Okay. So participants, any questions at this stage before we proceed further?
Sir, one question from
Yes, sir.
a participant.
Yes.
How can we evaluate the environmental, social, and economic impacts of additive manufacturing?
Yeah, it's a good question. So here we can already for evaluating the environmental, economic, and societal aspects of sustainability, there are indicators being formulated. And through those indicators, typically we can find the impacts, the environmental, economical, and societal impacts. The same analogy will be able to extend in the context of additive manufacturing, and accordingly we'll be able to quantify the environmental, economic, and societal performance even in the context of additive manufacturing. There are methods available, there are indicators available, and through such indicators we'll be able to quantify them. Fine. Are there any queries further?
That's it, sir.
Fine, sir. Yeah,
No.
let us proceed and then we'll see.
Okay, sure.
Sir, I hope I have like another 15 minutes till 9 p.m. Right?
Yes, sir. Up to 9 p.m. just you can take.
Fine. Sure. I'll try to comply with that.
Yes, sir.
Okay.
Thank you.
Fine. So let us briefly spend some time on this concept of smart manufacturing based on Industry 4.0. As we are all familiar, now we are presently in the fourth industrial revolution, where the concept is totally based on cyber physical systems, CPS, to create the smart factory. So typically the cyber physical system, it forms the base in the context of the smarter system. Even this term Industry 4.0 is also referred like smart manufacturing in the context of US, where ultimately we try to develop a smart factory incorporated with the sensors, powerful sensors, AI tools, and ultimately it enables a digital twin. And the base for this smart manufacturing system is the CPS, cyber physical systems, which has three important C's. One is communication, computation, and control. Totally information is a key beyond this, and it helps us to enable digital twin, because developing digital twin is a very important aspect. How we are connecting the physical scenario with the virtual scenario, how it is being interfaced. We do have like missions, we do have like robotic systems, and we need have to interface them through like sensors, or also we need to interface through the computing mechanisms, and we need to develop certain communication protocols. That configuration is of digital twin is very essential aspect. As if you see the factory, the present factories, there's something like with regard to the version 3, where the workstations are more rigid and like with autonomous robotic systems. Presently, we are having like completely flexible workstations, collaborative type robots working, completely networked systems. So in such a context, how we are able to execute the idea. So let me just spend the time on how how systematically we can develop a digital twin, connecting the digital scenario with the physical scenario, connecting various engineering functions, starting from product design, manufacturing planning, manufacturing engineering, production, and services, through the integration of several tools. And again, developing the digital twin, we need to ensure that it has to be supported with process models, and also higher order process models are very essential. So, and another important aspect is that the skill set, which is relevant for in the context of like a smart manufacturing system, it needs higher levels of creative and innovative thoughts. And also like a cognitive aspect is also equally important, because the problems which are happening will be more challenging, and it will be more unique, and any of the existing solutions we cannot apply. The problem will be unique, and we need to find a better solution for the problem. Very unique solution have to be found. The role of this cognitive science is also equally important. So let us quickly go through about this various technologies, starting from the robotic system where we need to develop collaborative robots, and also CPS, which forms the base, which forms the foundation for the systems. And additive manufacturing is having a key role. And the role of Internet of Things and Industrial Internet of Things is very essential because we have a situation of continuously monitoring the resources. How is it possible? Definitely, we need to have a typical IoT-based system and an industrial IoT-based system. So for every process, we'll configure certain sensors, and they provide certain information we need to capture, and that has to be transferred to a cloud server. And accordingly, we need to enable and we need to monitor. So this not only this process related attributes, but also maintenance related parameters, and also the impacts also we need to monitor. So these process models could be supported through this IoT based mechanisms. And we do have data analytics. And typically we are moving towards the scenario of a big data where the volume and variance of data are huge. And no longer the traditional analytics cannot be applied. We need to have a robust analytics, and advanced analytics are needed, for which the machine learning, deep learning modules also will help us a lot. And prediction modeling is also equally important. Okay, many of the issues in the context of the sustainable development of products and process have to be predicted. Many decisions have to be taken during early phase of design. Thereby, the development of products in a more sustainable way could be ensured. And also the role of augmented reality and virtual reality. AR, VR based systems are also very essential. So with an AR based system, we can go for complete digitalization of the machine manuals, quality manuals, and also the past maintenance data and past breakdowns, how it's being remedied. Everything could be captured very systematically. And also through a VR-based system, where it may not be possible to go to a field environment, which may be hazardous and which may not be possible. So it is possible to understand such field condition, or the field equipment, or the field machine tool could be understood through a VR-based system. It provides a very safer working and understanding mode of such field conditions. And also the role of simulation-based tools is also equally important, because we are beyond plant simulation we need to perform, process simulation and other simulation modules related to the product analysis and optimization is also equally essential. And system integration is very essential. So in the context of utilizing the competence, in-house competence, and also utilizing the competence external to the organization, how is it possible? How that integration both vertically and horizontally we could develop? That is again an equally important aspect which need to be taken care. So this is the scenario presently we are having, which makes the manufacturing system more smarter. So even in the context of smart manufacturing, this sustainable manufacturing is a very important aspect, and the need for integrating sustainable manufacturing in the context of smart system had been realized. And naturally, the technologies will augment, and the technologies have to be utilized more effectively. Thereby, we'll be able to make the smart factories to work in a more synchronized manner, wherein along with the resource monitoring, along with the energy monitoring, the impacts also have to be monitored. So typically, the life cycle assessment modules also have to be integrated, and it's more challenging. And this smart manufacturing has brought tremendous challenge for us to implement sustainable manufacturing context in the manufacturing concepts in the context of smarter system. And also now we are moving towards, we are ideating for Industry 5.0, where we are going to develop a cyber cognitive factory correlating the human ingenuity, sustainability, and resilience. The sustainability is another important focus dimension in the context of an Industry 5.0 based system. So this concepts of sustainability, they have very good relevance And accordingly, more robust modules, more robust methods, procedures, tools, techniques integrated with the technologies have to be developed. And this provides us very good scope for us to explore the concept of sustainability in the context of this smarter and something like cyber cognitive systems. And that provides a very good avenue for us to explore such um, concepts in the context of advancing manufacturing systems. Fine. I think let me spend few minutes for responding to the queries to you have at let me just respond. Sir, I can see the chat box. Now I can open the chat box.
Anyone can ask questions.
Yeah, similarly, I have one question in the chat box. What advancements in materials for additive manufacturing are currently being explored to further improve sustainability? Yeah, lot of research, materials related research are under progress, even in the context of like smart materials and shape memory materials, which are being explored in the context of additive manufacturing as we are moving towards like 4-dimensional additive manufacturing that is having very good relevance in the context of sustainability. Fine. So are there any queries? Please feel free to post in the chat box and
No.
or you may unmute and ask.
Yeah, one more question.
Yes, sir.
So what are the energy efficient layer deposition techniques to optimize the energy consumption or something? So
Could you please repeat? I am not able to see the question. Could you please repeat the
yeah,
question, sir?
what are energy efficient layer deposition techniques?
Energy efficient layer deposition techniques.
Yes, sir.
Okay. So now, even in the context of a powder bed fusion process and all, where we go ahead with like selective laser melting. So a lot of developments are happening even in the context of such process. And also we do have a lot of advancements happening in DED techniques that have very good scope for creating energy efficient pathways in the context of additive manufacturing. So that will contribute to develop energy efficient methods in the context of additive manufacturing.
And one more question, sir.
Yes, sir.
Is there any IoT and AI to monitor and optimize the energy which is using in the printing process?
Yeah. So in many of the industries and R&D establishments, research is going on, and also the methods are being developed to adopt the IoT-based systems for monitoring of this energy and other material consumption process. So that is a need, and definitely the methods are also being developed, and it is essential to go ahead with the configuring the IoT-based systems to enable this objective.
No, sir. Thank you, sir.
Are there any queries from participants?
So, dear participant, you can ask any question regarding this topic. Sir will answer.
Kindly feel free to ask any questions, or you may post in the chat box also.
Yeah.
Yeah. Yes, sir. I can see the question, sir.
Yes.
What role do government policies and industry regulations play in promoting the adoption of sustainable additive manufacturing practices? Yeah, it's a good question, because the policies and the regulatory norms are being formulated in the context of sustainability. Already it's under practice. Now, additive manufacturing is a key technology that is being taken ahead in terms of industrial developments. So definitely whatever the regulations being developed, they will have relevance in the context of additive manufacturing. And also now in the context of like smarter systems, new policies also may come across, may be formulated, and there we will have a certain relevance in the context of like additive manufacturing as well. Are there any further queries from participants?
Any questions? So if possible, can you provide the PPT, sir, for the
Yeah, I'll be able to send you, sir. Okay, sir, fine. I'll be able to send you. And before I hand over to the organizing team, so I would like to thank all participants for your listening to my lecture. And if you have any questions, you may write to my email, and I'll be happy to respond to your questions. And in any FDP, we need to have takeoffs in terms of certain inputs for the teaching courses, and identifying some projects, and identifying some R&D initiatives to enhance the research competence. And definitely in this FDP, through the sessions, you'll be able to have takeoffs from these perspectives. And I would like to thank you all. And also I would like to thank the organizers for inviting me to deliver this lecture as a part of FDP. So over to you, sir.
On behalf of our management and principal, sir, and from our department, we extend our sincere thanks to you, sir, for delivering this insightful session. And your presentation is a very nice, having nice critical aspects of sustainability. And we truly appreciate your time and effort, sir. Thank you so much,
Fine,
sir.
sir. Fine, sir. Thank you so much. Thank you all. Okay.
Thank you so much.
Sir, I'm leaving the meeting. Okay.
Yes, sir. Thank you, sir. Dear participants, we can meet again tomorrow. So the attendance link will be posted in the WhatsApp group, if possible. Okay, thank you so much.